Now we will discuss some length elements. For example, we have written already the r equals to x unit vector, means x in x unit vector, plus y in y unit vector in z unit vector. Now if we are having a length element, let's say that is a fraction of length, which is dl, then this dl is equal to dl, the x component of it in x unit vector, plus the dl, the y component of it in the y unit vector in the length element z in the z unit vector. And we know that these are equal. This dl is equal to dr, and this is equal to dx in x unit vector plus dy in y unit vector and dz in z unit vector. These are the fractional displacements along the three. Similarly, when we will be having the unit vectors like in the polar coordinates, then we will have them as dl, means this is x, y and z, and this goes into r, theta and phi. So we will have the length element like dlr, similarly dl theta and dl phi. We will have our length elements like this. Now what dlr will be equal to, so we will calculate that one. For example, this is our r unit vector, and the r unit vector is such that here this is our r vector. Now this vector will change and this vector will change along r, and let's say this is the fractional change in this one, and it will be dr. So we will have the length unit vector, which is dl, and the radial component, this will be equal to dr, and it will be in the r unit vector. Now let's say we are moving this same r. Let's say, let me design another figure here. Let's say this is r, and now this r is changing along the theta unit vector. So it will be, means it will, for example, this is the z axis, the straight, and this is our unit, this is our vector r. So along the z it will go like this. So let's say it moves a fraction, and this fraction, it's a curvature, and this will be then equal to, let's say it moves by some angle theta. So here it is. This angle, if this angle is very small, let's say this angle is equal to d theta, then we know that what about this one? Means this curvature will convert into a line if this angle will be very, very small. So what this will be, this is a perpendicular, means this is the base, this is the high part, and this is the perpendicular distance. So dl theta will come out to be r times this one. This is the sine component, so sine theta. So dl theta is equal to r sine theta. Now we know that when theta is very, very small, then sine of theta goes to theta, and that's why this fraction of length is, we are not taking theta to be very big, we are considering this as a straight line. So this means the dl of theta will come out to be r d theta. Is we write usually s equals r theta, and that is which is the arc length, and that is also due to this condition that for theta very very small we will have this thing equal to theta. So sine theta goes into theta. Now let's say we let me design this figure, and this figure is such that let's say we are having this figure is a bit difficult, so let me design this one. This is our r, and then it is equal to, let's say this is our r. Now this r is equal, this is our r, and we will have like here this one, I am considering this one. Now this is phi, and let's say we move a little bit here, means along the phi we move d phi. So it is in the plane of xy. This movement is in the plane of xy. So this movement is such that let's say we are having then this line and another line here a little bit away from this one. This is just falling in here, and then we are having a line slightly away from it, and it is this one. So this angle that is covered is equal to d phi. Like in the plane it moves phi distance, so it will be something completely parallel to this one here, and this will make like this here. So this phi angle moves a little bit, so it will come out to be rho times d phi. Means when this will go a little bit this, so based on this equation it will come out, this component will come out to be rho d phi, and dl phi is rho d phi. Basically this one is again perpendicular component here, so it will be rho sine phi, and when phi is very very less, then sine phi will go to phi, and we are taking this thing d phi is a fractional angle, so that's why this thing will be equal, dl phi will be equal to r, rho is equal to r sine theta, and d phi. So we got our length element, and our length element is such that our length element dl is equal to dlr and r unit vector plus dl theta and theta unit vector plus dl phi and phi unit vector, and this thing is equal to, what is DLR? DLR is just dr. So this is dr in r unit vector plus the dl phi, dl theta is equal to r d theta and theta unit vector plus r sine of theta and d phi in phi unit vector. So we got our length element like this, and from here I can write the volume element as the volume element here means the volume element in this one is equal dvr, I can write is d tau is equal to dx dy and dz here. So here the volume element will be equal to d tau, and it will be dlr, dl theta, and dl phi. And this is equal to dr, and then r d theta and r d sine theta d phi. So first I will write for r here, and here is dr, means dr and r here. So we will have r square dr, means the 3 will multiply r square dr, then sine theta, d theta, and d phi from here. So this is the volume element which we will later on calculate for the sphere. Now what about the area element? The area element is here. Any two can make us the area here. Like in a three-dimensional coordinate system, if I take, let's say, d area 1, and this is dx and dy, then it is in the z unit vector. And area element 2 is dy and dz, so it will be in the x unit vector. And area 3 element will be dz and dx, and it will be in the y unit vector. Like if I take the xy plane, then it will be along the z, means xy plane, it will be along the z. Similarly, yz plane, the yz plane, it will be along the x, and similarly the zx plane or xz plane, it will be along the y. So these are the three area element we can move any face of this one. Now in a spherical polar coordinates, we will have our area element 1, dA1. Any two components we can multiply. Let's say I multiply dLr and dl theta. So dLr and dl theta, if I do multiply, then this is equal, dLr is dr and dl theta is r d theta. So we have r dr and d theta, r dr d theta, and it will be in the phi unit vector. Similarly, dA2 here will be equal to dl, and this is, let's say I write theta and phi. So theta and phi, this will be equal to dl theta, r d theta, and dl phi, r sine theta d phi. So this multiplied with this will make r square, and then there is no dr, this and this are multiplying, so r square sine theta, d theta, and d phi. Similarly, area 3 element will be any two other components are being multiplied, like let's say we are having dlr and dl phi. These two are remaining, dlr and dl phi. Okay, keep in mind the other thing, if this is r and theta, so it is in the phi unit vector. This is theta and phi, so this will be in the r unit vector, and dlr and dl phi are multiplying with phi, so it is r dr sine theta d phi, and this is in theta unit vector, r dr sine theta d phi. So these will be the area elements, keep in mind the other things. For example, it's a spherical polar coordinates. So what will be the limits of r, what will be the limits of theta, and what will be the limits of pi, angle pi. So about r, as we know, r goes from minus infinity to plus infinity, but if we are making a sphere, then r is not going from below the zero, means it starts from zero and it goes to infinity. So there is, for a sphere, it is 0 to r, but generally this goes from 0 to infinity, means its limit is like this, while theta goes from 0 to pi. The zenith angle goes from 0 to 180. Like this is the z-axis, my hand is along the z-axis. Now this z-axis goes, means this is r. First it 0 to some r value it goes. So it makes this hand. And now this starts from here, and theta is changing, so theta has changed pi by 2. It has made quarter of a circle, and then again 90 angle pi by 2, so it is now 8 pi angle. And what it has made is it has made a semicircle, so it has gone like this. This theta, this angle theta starts from here, goes here, and reaches here. So it has made the D symbol or semicircle, and then I will have to move this pi from 0 to 2 pi, because it has made D here. I will make the D around 2 pi, means 360, and it will make a complete sphere. So these are the limits of this angle, these angles, the theta and the phi. So we have these is the limits. We calculated the area elements, we calculated the volume element, and now I can calculate example, which is example 1.13, and we can calculate the area or the volume of a sphere. This is example 1.13, and here we will calculate the area and volume of a sphere. In example, it says, let me recite the example. Find the volume of a sphere of radius r. But we will also calculate the area of this sphere as well. Now let's say I do calculate this one. Let's start with the area first, and let's say first I do calculate the area. Now the area, I am selecting the dA2 here, which is this one. R square sine theta d theta d phi, is 3 are involved here, so I am taking this one. You can try dA2 and dA3, and if your calculations are not matching, then you can write me in the comment and I will respond to that one. I will provide with the calculations. So this is dA2. Now this area, I will integrate this dA2 and it will give me the area of the sphere. So area equals the integral. Now the integral, it is dA2. And I know that what is dA2. So dA2 is this one. I will only write the magnitude of this one. Its direction, it's not required here. We know that it will be in the radial direction. So area equals integral. How many are there? Changes, means the theta is changing here and the phi is changing. So we are having two integrals, and the two integrals are d theta and d phi. As we are having r square, so let me write this one, r square sine theta d theta d phi here, and this is equal, as we know that r is constant here in the sphere. Radius is r, capital R, so we are having r square. Then we are having integral from 0 to theta on sine theta, d theta, and integral on phi from 0 to this we are having from 0 to pi, so this is pi, and this one is from 2 pi, from 0 to 2 pi, and this is d pi. We know that this completely is called a solid angle and the value of it is equal to 4 pi, but let me do calculate this one. So area comes out to be equal, this is r square, and now sine theta, its derivative here I can write it is minus differential of cos theta, so it will be minus cos theta from 0 to pi, and then it will be, the next one is pi, and pi will be from 0 to 2 pi here, and this is r square. The minus sign comes out here with this one, minus r square, then cos pi is minus 1 minus cos 0 is 1, so it comes out to be minus 2, and this one comes out to be 2 pi. So 2 comes out to be 4 pi, minus minus here plus, so we got this 4 pi r square. This is the area of the sphere. You can try with this one, you can try with the area 3, and then if your calculations are not matching with this one, then you can write me in the comments. And similarly, the volume will be equal if I do integrate d tau, and I know that now it's a triple integral. D tau is equal to r square dr sine of theta d theta d phi, and this is equal to triple integral r square dr, such that r is running from 0 to capital R, then integral from 0 to pi and sine theta d theta, and integral from 0 to 2 pi, and this is d pi. Again we are having, this is a solid angle, so this is 4 pi, but what about this one? This will come out to be r cube over 3, and from 0 to r, so r will just convert into capital, so it is 1 over 3 r cube, and 4 pi from here, so we got the volume equal to 4 by 3 pi r cube, and this is the volume of a sphere, a well-known thing that we have from the geometry. So this gives us the volume of the sphere. So now we will write some more, like the conversion of the gradient of the divergence and of the curl in spherical polar coordinates. So I will just erase this side and will do calculate the conversion. I will calculate for the gradient, means only tells you that how this can be done. You can then write for, you can say the divergence in the curl. So that calculation is not that difficult, although it will take time because there are so many terms involved in it.